Now we're going to take a look at solving some basic logarithmic equations, okay? So if you know any two of the three values in log base b of n is equal to p, so if you know b in p or n in p or b in n, you should be able to find the missing value. And the easiest way to do that is actually to convert back to an exponential format, and then you can just solve the exponential equation, okay? So we're going to go through three examples of this. So this first one, problem number 7, log base 9 of x is equal to 3/2. So the first thing I want to do is rewrite that in exponential form. So remember, the little number down next to the log, that's your base. So we have a base of 9. What's isolated, 3/2, that's the exponent. So 9 to the 3/2 power is equal to, the inside is what we're going to be equal to, that's the n value, okay? So this one I don't really need to do much work other than evaluate, well, what is 9 to the 3/2 power? And I want you to remember that 3/2 power, since it's a fractional exponent, that represents a radical, okay? And because the denominator is a 2, this is a square root, you can either do 9 cubed on the inside, or you can move that cube to the outside of it. And we usually moved it to the outside so that we could figure out the smaller number first and then do that to a power, okay? So the square root of 9 is 3. 3 cubed is 27. So that means x is equal to 27. And the important thing when we're doing logarithms is just to make sure that we don't get a negative on the inside and we don't get a negative or a 1 or a 0 for the base, okay? So we need to make sure those things are happening. So we have to have positive values for the base and the number inside, and the base cannot end up being 1, okay? So there's our first problem. We get x equals 27. All right, for problem number 8. Again, I'm going to give you a logarithm, and you're going to write it in exponential form so that you can try to solve for the missing variable. So for problem number 8, you have log base 8 of 128 is equal to y. Log base 8 of 128 is equal to y. So step 1 is to rewrite that in exponential form. So the base, the little number down next to log, is an 8. The exponent is the y this time, so we're going to have to do a little bit more work than the last one. And the inside is what we're equal to, 128. So we need to solve 8 to the y power is equal to 128. And the only way for us to do that is to do same base. The smallest base for an 8 is a 2. So I'm going to make this 2 cubed to the y power. And then I need to figure out, well, 2 to what power is 128? All right, so if we work through that, 2 to the 7th power is 128. Now, power to a power, we can multiply those exponents. So this is really 2 to the 3y is equal to 2 to the 7. And now we can apply that property of equality for exponentials. Because the bases are the same, these two exponents must be equal to each other. So now I'm going to work back over here. We're going to have 3y is equal to 7. So y equals 7/3. All right, and again, I just want to go back and look. There were no restrictions on the answer for a logarithm, just the base and the inside. So this is our final answer. Okay, one more of these. For problem number 9, we're going to be solving for the base now instead. So here's number 9. Log base z of 25 is equal to 2. Okay? So start off by writing that in exponential form. So the base is a z. The exponent is what we're equal to, that's the 2. So we have z squared is equal to, the inside number is 25. Okay. So z squared is 25. The only way to solve that is to square root both sides. So I'm going to get z is equal to positive negative the square root of 25, which is 5. Okay, so I'm square rooting both sides, putting the plus or number plus minus on the negative numerical side. Sorry, tripping over my words there. All right, and now we just need to go back and make sure that that answer matches our definition. And when we look right here, z is the base can't be negative. So that means I need to get rid of the negative here. The final answer is just z is equal to 5. It cannot be negative 5 because I can't have log with a negative base, okay? So the final answer is just z equals 5 here. And that's how to solve when you know 2 out of the 3 values.